Okay, so welcome back, and today we're going to start talking about another topic related to exponential growth or exponential functions, and that's compound interest. So there are lots of places where compound interest occurs, and well, in investments, loans, for example, in qualified plans, like anything that's dealing with investments, like IRAs, 401k plans, stock markets, and things like that, have exponential growth at times. Okay, especially if there's a constant interest rate. Now, how do we handle this? It's pretty much the same way. Now, the formula is a little bit different as well, and there's some other terminology that I want to go over, but here's the formula. Now, we start with a growth. Now, the thing about compounding, compound interest means that you're earning interest not just on the original amount, but you're also earning interest on the accumulated amount. Okay, so every month, let's say, or every year, you get interest on whatever amount you have, let's say, in an interest-bearing account. Let's say you have $1,000. And so you'll earn interest the first year on whatever your initial deposit was. But then the next year, you're going to earn interest not only on your initial deposit when you first open the account, but on the amount of interest that was added to it after the first year. Okay? So every year it compounds. Okay? And so that's where the idea of compound interest comes from. Okay? Now, the interest rate, or what we call the annual percentage rate, or APR, or what's also called the nominal rate, okay? So on your credit card statements, when you look at your credit card statements, it'll say APR, that's the nominal rate, but there's also another rate which is called the APY, the annual percentage yield, but that's something different. The nominal rate and the APY, the annual percentage rate, are always going to be the same if it's an annual compounding, okay? If you're doing some other compounding, like compounding monthly or quarterly or weekly or daily, then the nominal rate and the annual percentage yield will be different, okay? But that's a side issue. Okay, so this is usually R, represented as R, okay? So the nominal rate is given pretty much for any compounding other than annual. Okay, so R is the rate. Okay, so R is the rate that we're talking about. Okay, so R equals rate. Okay, that's your APR. A is the accumulated amount, or the future value is another way of looking at it. So the accumulated amount, okay? P is the principal. That's your initial deposit, right? So that's this assumes a one lump sum. So you just deposit the money into the account and you just let it ride. Okay, so this is the principal or present value. Principal or present value. Okay? N is the number of compounds per year. Okay? Number of compounds per year. Okay, now that's important. So that means if I'm compounding annually, then that's going to be 1. N is going to be 1. If I'm compounding monthly, then N will be 12. If I compound weekly, N will be 52, right? Because 52 in a year, weeks in a year. If it's quarterly, then N will be 4. Okay. If N is semi-annually, that means every 6 months, then N is 2, and so on. Okay. And T is the number of years that they go by. So number of years. Okay. So incidentally, the T and R must agree on the time, on units, okay? If if t is years, right, so t is the number of years, r has to be an annual percentage rate. Okay, so these two have to match, r and t. Okay, and I think that's it. Okay. Let me check. Is there anything else? Okay, that's it. So let's do an example. Okay, so if we invest $3,000 in an investment account paying 3% interest, compounded quarterly, how much will the account be worth in 10 years? Okay, so in this case, what? It says we are investing $3,000. That's P, right? P is 3,000. And we're investing for at an interest rate of 3%. So R, now here's the other thing too. R is given as a decimal. So the problem will always give a percentage, a rate as a percentage, but when you put in the formula, it's a decimal form. So that means if 3%, then R is going to be 0.03. That's how we're going to write the rate R. And then it says it's compounded quarterly. Well, quarterly is how many quarters in a year? 4. So it's going to compound 4 times a year. N is equal to 4. And what else? T is 10 years. So we're going to let it ride for 10 years. And so now the question is, how much money will we have? What's the future value after 10 years? So let's plug and chug. So we're going to put everything in. So it's 3,000. 1 plus R is 0.03 divided by 4. And then this here is going to be, the exponent is going to be 4 times 10, or 40. So now all we have to do is simplify this and stick it in our calculator. So let's do that. So at this point, you just have to stick it in your calculator and come up, and I'm going to round to the nearest penny. Normally you round to the nearest penny or whatever denomination is given. Okay, nearest dollar, nearest penny. Okay, so let's see here. Okay, give me 1 second. Okay, so I get $4,045.05. 4045.05. Okay, so that's my future value. By the way, this is my future value. So I deposited $3,000. So how much money did I earn in interest? Well, interest is really easy. It's just, I started with $3,000 and that's all I put in, right? So interest is going to be whatever my future value was, my accumulated amount, minus my principal. So in this case here, it's going to be $1,045.05 approximately is what I earned in interest. But again, that's incidental. Okay, so my accumulated amount that I'm going to have, that's to answer the question, after 10 years, I'll have $4,045.05, of which the interest earned is $1,045.05. That's it. Have a great day.